Microscopes have many uses. One of them is for counting things that are too small to be seen with the unaided eye. In this video, we'll look at the hemocytometer, a device that's used to count particles and microbes and larger cells under the microscope. In this segment, we want to look at some mechanisms of making counts under the microscope. We're going to be using what's known as a bright line hemocytometer to do some particle measurements. Now, particles can be cells or they can be actual physical particles. For instance, if you're working with microparticles to develop an assay. We always want to keep our hemocytometer in its box. Okay, these will last for a very long time if we take care of them, and they are fairly expensive. So let's quickly remove it. And the first thing you'll see is a small cover slip. These are special heavy-duty cover slips, and we keep them in a little plastic bag. The hemocytometer should be cleaned before it's put away, and we usually wrap it in a piece of lens paper to keep it clean. Okay, and that's basically what the device looks like. Now, this is specially etched glass, and it's been optically ground with flat with diamond powders and paste to give us a good surface. And when we get under the microscope, there's a very small grid that's been put onto the surface of the glass that we can use as a counting area. So let's set our cover slip here to the side. Now, the cover slip should be nice and clean. Again, everything should be put away clean. But if necessary, you might want to polish it with a Kim White to make sure that it's nice and clean. Now, for this demonstration, I'm going to cheat a little bit and use some colored particles to make it easier to see in the video. Okay, so let me draw up a little bit of a sample. Typically, what we're going to use a pipetter with a pipette tip, and as you can see there, you kept it nice and orange. Put my sample down. You always want to put the cover slip on first. It's inappropriate to put a drop of liquid on there and then put the cover slip on. What the cover slip does is it forms a small chamber. Our counting grid is now in this area, and see these two small areas right here, right on the end? That's for filling the chamber. So we're going to very carefully pipette a small amount of sample in there. And as you can see, it turned nice and orange because I used an orange dye. And now we'll come over here and do the other side. Be careful not to get any air bubbles in. Okay, now that chamber is full. Okay, we've mounted the hemocytometer now into the microscope. Now, this particular technique leverages your experience with using the XY translation stage and finding the specimen layer. So we're going to start off here by using the fine focus. I've already done the coarse focus adjustment for you, and as we bring the fine focus a little bit, we will see the counting chamber just come into focus. Now, this one is filled with water, okay, and what we're interested in are there are 9 squares that are present. For instance, if you look right here in the center of the field right now, you see a box with 16 squares in it. That's the upper left. If we will ignore the one in the middle and look at this box of 16 squares, that's the upper right. We'll ignore this group with the horizontal lines through it. Here is the lower right, and then moving over in this direction, we have the lower left chamber, and we also use the center chamber. So we're going to use these 5. Now, the center chamber has been subdivided into even smaller units. Now, as I mentioned, this particular counting chamber was empty of sample. Well, let's look at the other one real quick. And for this demonstration, I've used some very large particles to make this very easy to count. We're looking now at the upper left counting chamber, and what we want to do is to drill down to the 100 magnification. Right now we're at the 4 power, and so we're looking at it at a total of 40 power, including the objective, and we want to drill down to the 10x objective. And now we're going to very carefully, using the fine focus, Going to look in this chamber, and now we want to count all 16. Okay, so here's the top chamber. Now, let's look quickly at these two that are in the center. I won't count either of those. One of them is outside the chamber entirely. One of them is mostly outside the chamber. Different laboratories have different protocols, and you should follow, of course, whatever your laboratory director says. But in that particular case, we don't count things unless they're mostly in, and that one is mostly out. So we would count 2, 4, 6, and now we're going to move the scope down. There's nothing at all in that row. There's 7, 8, 9, 10, and 11. Okay, so the upper left chamber has 11 particles. And I'd record that someplace, usually in the laboratory notebook or on the SOP. So now we want to move to the next chamber. We're going to go back up, quickly focus. We're going to now center into the upper right, back down. Okay. There's an odd looking particle there. We won't count that as 2 particles, we'll count that as 1. There's an artifact, we won't count that one at all. So on the second row there's 1 particle, that gives us 2. On the third row there's 2 more particles. The other ones that we see are there outside the counting chamber. So we're at 4. Now that's a hard one to call. It's obviously more than 1 particle, but how many? I'm going to score that as 2 particles. Okay, and so we have 2, 4, and 6 particles in the upper right chamber. Looking quickly at the lower left, there's 1 particle, 2, 3, 4, 5. That one's mostly out. 6. That one's mostly out. 7, 8. We have a couple of particles there that aren't dark. I'm going to score those as artifacts. So that gives us a total of 3, 4, 5, 6, 7, 8 particles. Okay, let's move now over to the next chamber. Now on the first row, there's 1, 2, 3. I'm not going to score that blob there as a particle. So 1, 2, 3. I'm going to score that one as 4. Coming down to row 2. Now that particle is mostly in, so that's 5. Okay, the next row, 6. I'm going to score that blob as 7 and 8. There's 9, 10, 11, and 12. So lower level is 12 particles. And finally we want to come up to the center. And to do that, I'm going to go back up to the 4 power so that I know where I'm at. Okay, there's upper left, there's upper right. Right here is our center chamber. It's 16 squares, which are each subdivided. And so now let's drill down and focus. Okay, so we go 1, 2, 3, 4. Not going to score that one. 5, 6. Artifacts, 7, 8, 9, 10. It's probably a cluster, but we're just going to score that as 11, 12. And that's it. The center contains 12. Now, a hemacytometer has some limitations. It can't count anything that's smaller than a micron. It can't count anything that is transparent. In some cases, we have to dye them. And it's very difficult to use on cells, especially bacteria that are very motile and move outside the counting chamber.